today we look into integration by substitution for definite integrals. So for this integral on screen, we need to find something that's suitable to substitute for. And we notice that this 1 plus e to the power of u, its derivative is going to be e to the power of u. So we'll make a nice substitution for that, as well as for what's inside the integral, and then obviously change the limits of integration, and then this integral becomes simple. So let's go ahead and do that. Let's make 1 plus e to the power of u equal to x. So that means that the derivative of x in terms of u is going to be e to the power of u. Okay, now since we're integrating u from 0 to the natural log of 2, we will now be integrating x from, so we substitute in 0 into this equation, and we say 1 plus e to the power of 0 is equal to 1 plus 1, which is equal to 2. And then we substitute in 1 plus e to the power of the natural log of 2, because these are now our new limits of integration that we're working out, which becomes 1 plus 2, which is 3. So to get our new limits of integration, what we are doing essentially is we're taking our substitution and we are substituting in these limits to find our new limits of integration. Okay, so let's rewrite this integral now in terms of x. So we have now the integral from 2 to 3 of the square root of x dx, because I substituted in x for 1 plus e to the power of u, and I substituted in dx for e to the power of u du. So x square rooted is x to the power of 1 over 2. And when integrating, we add 1 to the power, so x becomes x to the power of 3 over 2. And then we divide by the new power, with the new exponents, and we get 2 over 3. And this integral is from 2 to 3. So now we substitute in 3, and we get 2 over 3 times by 3 to the power of 3 over 2, minus 2 over 3, which we can take out as a common factor, minus 2 to the power of 3 over 2. Okay, and now 3 to the power of 3 over 2 is 3 cubed and then square rooted. So 3 cubed is 27, and 27 square rooted can be equal to 9 times by 3 square rooted, which is 9 square rooted times by 3 square rooted, which is 3 root 3. So we have 2 over 3 into 3 root 3, and then 2 to the power of 3 is 8, and then now we have to square root 8, which we know to be 2 root 2. The same way that we did it for the 3 root 3. And so now distributing this 2 over 3, we get 2 root 3 minus 4 root 2 over 3. And that's the final integral solved. So that's the final solution to this definite integral that involved integration by substitution. Hope you found this video useful, and if you did enjoy it, please leave it a like and subscribe for more. Thank you.